So, nice that you're here for this afternoon session of our conference, QtDevCon. This next talk will be probably not about Qt, probably about C++, right? And maybe also about the aspects that come along with it once you start being popular. You're popular. This is Niels Lohmann, and people who know C++ and JSON probably also know your repository. I don't know if they know you, but I'm sure you will introduce yourself anyways.
Let's change that.
Yeah, so you can start your talk and have lots of fun. Yeah.
Thank you. I changed the title a bit for two reasons. The first one is the number went a bit up, and the second one was that I tried to give some lessons learned. That it's not about talking about myself and how fun it is to have a GitHub project that some people like, but rather to tell you what you can take away from it. I hope that you will learn something, maybe not 18 new things, but some of that. About me, hi, I'm Niels. In the internet, I'm N. Lohmann, which is my first name and my last name. And when I got invited here, I was thinking, what could I talk about that you're interested in? And I'm currently working on automotive navigation software. We work with digital maps. I have a background in formal methods back in the day, and this is what I could talk about. Fortunately, I can also talk about C++ and JSON, and there's you. I don't know what you can expect. I have nothing to tell you about Qt. The last time I wrote Qt was in 2006, and that was it. So I hope that in this intersection we find a topic that can be interesting for both of us. Some disclaimers. I will not introduce JSON. It's not relevant for this talk. I will only show a single snippet of C++, just for the sake. I will report of my own views and experiences, so I'm not talking about my employee, I'm not talking about anyone, it's just me. And this can be as interactive as you wish. So I'm not sure where the guy with the microphone is, but if during the talk you have anything you want to ask or tell or whatever, please do so. It's already late. I don't want you to fall asleep and then afterwards wake up and have a question. Just to have you woken up a bit, who knows about N. Lohmann JSON, the library? Okay, good. Some people know why I'm here. You may not know why we wrote it in the first place, or I wrote it in the first place. So some history before I go to talking about the anecdotes. I needed a JSON library back in the day, and for a university tool suite, so we have had a lot of tools, and we needed to have some diagnostics, and JSON was a good way to get diagnostics from A to B. And I started creating JSON by hand, and you know the first thing you need to do is at some point you have this loop with an if, and then am I ready yet? Then make a comma and continue, and at some point you have a proper JSON library. So ... then you have a proper JSON library. Then a colleague proposed, well, if you had a parser, that would be nice, because then you're not just dumping the code, but also reading it. And at that time, C++ 11 came along. And we did C++ 98, and it was nice to learn about it, but the daily work was not the right place to learn C++, so it started to be a side project, and especially initializer lists helped a lot to build a nice syntax for the library. And then I decided, let's have that as a toy project. It was nice because it was a library already. It was something that could be used in different places. We used it ourselves, so it was not something nobody used. It was something that we used ourselves. And then it started. And in 2013, I created a GitHub repository. And it was at the time where Scott Myers announced his book, Effective Modern C++. And the modern C++ was a catchphrase back in the day, and I said, why not? Let's call it JSON for modern C++, because I was using C++ 11, which back in the day was very modern. And then it took, I don't know, 2 years for the first release candidate, and then another half year for the first release. So I really took my time there. Then it was a year for the 2.0 release, another year for the 3.0 release, and since then we're in this 3.something release track. The 3.11 will release soon, but I'm here now, so not today. So basically, that was the timeline. And now I'm going to talk about anything that I picked up in the time between. Something to just summarize. What is it? That's the one snippet of code. It's a C++11 single header library or header-only library that has the STL as only dependency, so you can drop it into your code and it should work. And it gives you a type called basic JSON. It's templated, or JSON if you use the standard templates, which can act like a dict in Python. You don't need to worry about it. It can be a string, it can be a number, it can be an array, it can be a map, it can be Boolean, it can be null, and then you have JSON. What makes it nice is that you can drop all kind of syntax on it. So you see on the right that if you want to use initializer lists, it can be initialized as an array if you just have the quotes. If you give it a pair of a list of pairs, then you have an object, and you have a user-defined string literal operator underscore JSON, and then you can just dump in a string and make a JSON out of it. So a lot of syntactic sugar, which back in the day was pretty cool because so far C++ looked like C. We didn't have anything nice, and then when it started. Things that make it nice today is user-defined type support. So if you help the compiler a bit, then it's easy to take whatever widget class you have to create a JSON serialization out of it and to read it back in. So that's really a nice thing, which I use personally most of the time. If I use JSON in C++, then it's mostly about getting things down to the wire, dump it into some server or get it from a server and unpack it again, and that's really helpful. And we started implementing a lot of binary formats, which help you, if you put it on the wire, that the payload is getting a bit smaller and it's not going too big. So that is that. Some numbers. In the end, it's 17,000 lines of code. And if you ask covering services like coveralls, it has a metric called relevant lines. It's non-whitespace, non-command, and non-structural. So a line that is only a curly brace is not counted as a code line. Then we are down to 6,000 lines, so it's not too big. 600 functions is a bit much. It's because a lot of parsers are in there, so a lot of helping things. The community grew over the time, so we have 227 contributors, a lot of commits, a lot of pull requests, 40 releases since then, and also the inflow of information has got bigger, so we now have over 2,000 issues and 500 discussions. GitHub discussions are a new way to communicate on GitHub, and it's used quite widely. It's similar to Stack Overflow. I personally don't look on Stack Overflow. There may be more, but I don't have the time for that. And it's now at 25,000 clones a day, and it reaches 30,000 stars. So what is about the stars? If you're on GitHub, there's a possibility to star a repository which can have any kind of semantics you give it. It can be, I want to bookmark it, I want to show appreciation, I want to be reminded of this, whatever. And if you take this metric and compare it to other projects, then the repository is now in the top 15 of the C++ project on GitHub. If you look at the 14 above it, then only Dear Imgui is, to my knowledge, a repository by an individual. The other stuff is like Microsoft Terminal or Apple Swift or something like this. So it's not a currency. I can't buy anything from the stars. It's just nice to see. And it's something that every once in a while where I don't find the time to work on it or I totally forget about it, this is something that is nice to look on it, that people find it useful. Apple finds it useful. It's on iOS and macOS. I'm not sure where it's used otherwise. I know that it's used by German car manufacturers. That is something I know firsthand. And now it's about why should people use it. There are way faster libraries. It's like every year you have the newest, fastest JSON library out there. Right now it's YY-JSON. Before that it was SIMD-JSON. So if it's about speed, take these ones. We focus on simple integration and an unsurprising API. Unsurprising means if you have a vector next to it or anything else, a string view, whatever, you shouldn't think about how can I access the fifth element of a JSON array. You should just use subscript operator or .add, and it's boring. You don't need to think about it. That's what we try to do. All right, so much for the setup. This is what it's about. And now I promised you 18 lessons learned. I categorized them in different stages of the project. So the first one is starting, assuming you have too much time and you like programming and you want to do open source. At some point you start, and I just collected the things that I found nice or noteworthy when you talk to people outside of our industry or out of our profession. The first thing is everything is free. So if you want to build, I don't know, a chair in your free time, you have to buy wood. If you want to build a car in your free time, you have to buy parts. If you want to make software in your free time, everything is free. Your operating system, your IDE, all the tools. I'm using JetBrains. JetBrains is giving away all the licenses for all their tools if you do open source. Everything is free. So there's basically, if you assume time is free, then everything is free and you can just get started. That may not be a surprise to you, but I found it very motivating to say that it's not excluding too many people. It's excluding all those people who have different jobs and really are struggling to get by. But if you do have some time, nothing is stopping you doing open source. That was an easy one. Another one that quite early need to understand, I will never understand C++ fully. And even if I would be, then C++ is developing faster than myself. There's always so much to learn. I still think Svine is magic and ADL is magic, and that is not even new, that is old. Visual Studio, I'm not using Windows myself. Visual Studio is always adding surprise when it comes to implementing C++. I know that those people working with Visual Studio really like it. I found it challenging to support it, but nonetheless, it's nice. You learn something, you get surprised. Package managers, there's so many package managers. There are so many opinions about package managers. You will never understand all of them. Of course, we try to support C++ 11, and we do, but new features come along. So you want to support a string view, or you want to support something, ranges, whatever. You have to backport a lot of stuff in order not to have two different code paths. That's always a challenge to go back and say, okay, that thing in C++ 17, how exactly can I express that in C++ 11? Compiler support, I have a whole slide of that. Compiler bugs, if you're working long enough here, usually it's not the compiler. Of course, it's your bug, but sometimes it is the compiler. And that is maybe a C++ stuff, but you learn. And concept allocators, everything. And the last thing, people can be very emotional about C++. I haven't attended Python conferences, but I can't imagine guys to be so into the language and really shouting at you and like, you're doing it wrong, it has to be this way, and I don't know. So once I accepted that, everything is nice. Then you can lay back and say, okay, I won't understand all of this. If I get a merge request that adds a lot of things that makes my life easier, I may not need to understand it fully. It helps others. So it's not, at some point, it's not my code base anymore. It's community's code base. Standards. Standards help a lot to get started. So if you get started, a lot of things are not, like JSON is standardized, UTF is standardized, a lot of things are standardized. And if you start to be helpful to others, implement a standard. If it's not in the STL or in the standard library, then this can be your niche. This can be what you want to do or what is helpful to you. But if you do it right, so if you well implement a standard, add all the test cases, make sure it communicates nicely with other libraries or other languages, that is already very, very relevant and helpful. And for me, the side effect, at some point, you can look into a standard and start implementing it. That when you start fresh, a standard looks like a legal document. They first tell you what may and must and all these capitalized words mean, and then you have so many definitions and very few examples, and you ask yourself, what is this about? And at some point, it gets easier. And yeah, this me helped a lot. The last thing, to start release often and use semantic versioning. I have the obligatory XKCD comic on the right. Everything breaks someone's workflow. Right now, we have the discussion what goes into the public API. So the idea of semantic versioning is that whenever you break the public API, you have to increase your major version number. But what is the public API? Is it just the names of the functions and the arguments? Is it the ABI? Is it a CMake option that you renamed? Is it the exception message of an exception that you throw? Not the type, but if you call .what and you get a string back, am I allowed to change that without making a breaking change? You never know. So the 4.0 release will be great, or it will never come at all because it seems such an important step after 5 years being on the 3. Release. So that's very difficult. And in the middle, I had a line that I skipped. I see this now from corporate side. So companies seem to be very interested in how you version stuff. If you only have one version and you don't release a second version in the next year, then they seem, oh, this is an abandoned project, let's not use it. So if you want to be adopted, it's not just about the license, it's also about, can you express somehow that you take it seriously and that you really want to keep working on it, and then releasing often, at least from my experience, is more important than having many features. It's really about showing that you're active and that you're willing to address bugs, address issues, and you want to keep playing. All right. So now the basics are gone. Now it's about growing. It's about, for some reason, after the first years, there was a JSON library. We implemented some features together with a bit of growing community, and now it comes to about people start using it. It's like, oh, suddenly you realize people are out there and they want to do something with your stuff. I realized I have no idea what my users are. I knew my needs. I knew I just want to have JSON from A to B. And the problem is the library uses templates, so we have to ship a header. It's not possible to just make a static library out of it. So people need to compile it themselves. And even now, even 11 years later, C++ 11 support is sometimes hard to take for granted. People are stuck in their system where they're not allowed to upgrade for reasons we heard earlier this morning. Misra, for instance. You have some project set up where someone said this is the way to do, and if you then want to change anything, you lose all your certification and you're not allowed. Then you have embedded systems where some STL headers are not part of your STL. So suddenly the compiler just chokes on your library because it doesn't have an IOStream header for whatever reasons. You have things like min.gw, which don't know how printf works. So they tell you your code is wrong because we can't compile it. And then you ask yourself, is it something that's worth changing the library to? So seeing real users use your code helps you to understand that you can't take anything for granted. Very crazy people do very crazy things with C++ and JSON. So really about throwing an exception as a JSON object, because then it's easier to dump it to some kind of log file. So you see throw basic JSON something. Then I tell them that that one can throw too, and that can be dangerous and whatever. So the advice is never make too many assumptions. If you build a library, it's meant for users to use it, and you never know how a library is used. So just relax and say, you never know. People discuss a lot. So they come, look at your open source library and say, it's missing feature X and Y, but they're clever. They're not saying this is an issue. They say that's a bug. They say your library is broken because it doesn't support commands. And then you say, where in the standard are there commands? No, it's not in the standard, but we use it at our company. We have that one JSON library that supports commands, and now your library is breaking because you don't support commands. And then suddenly it's my problem. And then you discuss and say, not really, I really don't want to go down that road. If I accept commands, then the next guy comes along and say, the commands are gone if you serialize code again. So, or commands are not properly pretty printed. Or if you support commands and I have some magic keyword in there, I want to do this and that. And then You have a long discussions. JSON says an object as an unordered sequence of key value pairs. This unordered is something that makes people crazy, because if you use a standard map, then it's ordered by alphabet. And then they say, well, I want to have it unordered. Say, well, unordered says the order is not specified. I'm using alphabetically ordered. So what does unordered mean for you? Oh, the insertion order. All right. So they discuss that the library is broken because the implementation of unordered is not the way they want to have unordered do it. So we have a solution for the first two things, because at some point I gave up. Postel's robustness principle is to be relaxed on the stuff that you accept and to be strict about the stuff that you generate, which basically, if you write a parser, it means if there's a comma that doesn't belong there, you're done. You create an error message and say, thank you. No, you shouldn't. You should be helpful. You say, okay, maybe I can parse it without that comma because you tried, and I shouldn't be the one to tell you that your JSON is wrong. So you discuss about the robustness principle, but then you can discuss about another RFC about the harmful consequences of the robustness principle, which basically means if you go down that road, then anything is proper JSON. Because you tried, you didn't try hard, but you tried, your library should accept it. So no curly braces, but I really meant an object. No comma, but listen, there's white space in between, you should go there. People don't like the project's namespace, which is still Niels Lohmann since we started the project 6 years ago, 8 years ago. And what to put in repositories is also making people very anxious. Like tests, should you put test case in the same repository? I'm using it as a, people use it as a Git submodule and they say, oh, it's too big. Well, I don't care, don't use it as a Git submodule. And these discussions never end. So that's the lessons learned. It never ends. So there's always time you need to put aside to tell people that this discussion is old. It has already been discussed 50 times, and the answer is no. And an open source project at this scale, or scale meaning me as a maintainer, is not a democracy. So it's not that people came in and say, oh, if this topic comes up the 100th time, then you have to say yes. No, I don't. But that's something you need to learn. Tooling. C++ has so many cool tools, and the more you learn tools, the easier your job becomes. So I put a lot of them on the slides here that we're using. I think hardly any of them are surprises, but there's a tool for everything, and I learned that in corporate worlds and in companies, you usually use too few tools. You don't know. It's done as you want to, as you do it all the time. It's not the time where people bring in new tools just to experiment. And if you have the freedom to do whatever you like, you can do whatever you like, and you can try new tools. And a bonus for you, there's a Docker image where all these tools are on. It's a Docker image we use in the CI, and that is Linux with 50-something different C++ compilers, and that helps a lot. It's not all of them, but it's the one we're using in the CI, which brings me to the next thing, testing. If you're doing something in your free time, then you don't have the time to do so much, can't put so much effort in manual work, so I try to implement as much as possible, make it automatically. And as I said, the library is shipped as a header, so other people compile it. And if I want to change something, I want to make sure that I don't break anything, so I have to try on as many compilers as possible. Unfortunately, C++ is not the language where you say, I'm following the standard, so it works. So there's so many if-defs in the code because different compiler versions don't agree on how to implement standard file system, for instance, or implement, I don't know, so many things. So we test with 53 compilers on 3 operating systems, on 3 architectures. We start with GCC 4.8 or Clang 3.5 and go all the way up. And there was recently something broken with Clang 8. So the code only broke on Clang 8. Good to have a test. We have 100 million tests including a complete test suite for Unicode. So for Unicode, we have every legal byte is tested, and the prefix of every illegal byte is tested. So when there's a bug ticket coming up from mostly some people in China that tell me, oh, you don't have UTF support because there's this one Chinese symbol that you can't parse, I can relax and say, no. It's tested. Maybe it's not UTF-8 what you're doing. Maybe it's some ISO whatever encoding, and that's it. We have 100% line coverage and 92% branch coverage. These kind of metrics don't mean too much. So of course you can argue that that doesn't tell you that the quality is good. But I would guess that a lot of people work on code bases that don't have these metrics. And believe me, if you go from 99% to 100%, you will find another bug. Because there was a reason that was never tested, that 1%. So it's good to have that. We test with Clang W everything, with I think 8 exceptions, and right now 277 GCC warnings. That is a screen full of warnings, and there are no warnings. And then again, this comes because the library is put into your environment. If you have W something, W error, I don't want to be the guy who breaks your code. That's why you have to put in a lot of effort there. And yeah, that's the work I like to do, because if I would do this at work, I would go crazy. We use a lot of tools. Yeah, the usual ones. We use Valgrind and address sanitizer, because then again, there can be errors that only one of them detect. And we test a lot of other things. Compiling it with different standards, compiling it with different CMake flags. We test indentation, a lot of things. We have a lot of examples, and we check that the examples compile, because then we have always self-contained code that we can give to people. Yep. And the nice thing is, with GitHub, you have GitHub Actions. You can do this with every commit. And if you have a box telling you that 100 tests are successful, then, or 100 checks on different things, that helps a lot. And this helps only looking at merge requests where you know it's good enough that coverage is still at 100% and it runs through on all these architectures. That helps, because in the end, I'm doing this in my free time. I don't have the time to carry people through their merge request. If they bring something and it's broken, the system can tell them that it's broken. They know exactly where it's broken, and I can come in later and have a look at this. Or other people in the community. Another thing, let Google do the testing. Who knows OSS fuzz? All right, a lot of people can learn something. That is good. Google has a service where they have a lot of machines doing fuzz testing at 24/7. So if you have a public code base, you tell them, listen, here's my code. I have some parsers, and Google is creating random inputs for these parsers 24/7. And they run your parser together with address sanitizer, undefined behavior sanitizer, and they're doing this at a scale that only Google can do. Since the integration in 2016, we have 28 billion inputs thrown at the library, and we got 64 inputs that could have caused crashes. These inputs came after the test succeeded, after we implemented a standard, after we were sure that everything is fine. And you have an example that can be like 4 kilobytes of JSON, and that leads you to some kind of buffer overflow or something. And then OSS fuzz has an option, or libfuzzer has an option to reduce the examples, and they look really like a human has written these test cases. It really looks like this evil tester that wants to show you, listen, there's something broken, and its standard thing is something like opening bracket, opening bracket, opening bracket, opening bracket, until you have a Stack Overflow. That's the easy thing, but it can also be something like number overflow in a situation where it shouldn't be a problem, but it is. And then you have like 15 bytes, and you look at 15 bytes for a binary format, and you ask yourself, why can an example be so short and still break my code? And even nicer, everything that is found here is still a regression test. So with every commit, at first all the breaking tests are checked whether they're still broken, and then everything that was a was an error before is tested, and then new things are generated. And that's really nice, and that's all for free. Basically, Google is doing this for free. If you have open source, you can use it. Documentation. If you want to provide support, then it starts with people asking questions, and then you send them an answer. But at some point, that doesn't scale, because even if you have the same question or the same answer again, the questions are different. So if I have a question, I may not find it in the list of issues, or I haven't searched for it, or I haven't seen it. So the only chance I have right now is to answer questions once, and if it comes up a second time, it should be a page in the documentation. And for this, Doxygen is not the right place. So Doxygen is nice to generate stuff out of code, but nobody ever looked at a Doxygen documentation and say, oh, this is so nice. This is a pleasure to read, and now I know exactly what it's about. C++ users are used to use cppreference.com. At least this is my go-to place to look at the STL. And we mimic this with mkdocs. I have a screenshot in a second. We'll use a lot of examples, self-contained examples that start with include and that end with a main function. So you can throw it at people and say, everything you need to know is in this code. So it's not that I show them a function prototype and say, you figure it out. You just need to set it up, etc. I just say, this is the function you're interested in. That's it. And now, since early this year, we have more documentation than lines of code. So that is currently the biggest investment I'm doing right now is I write documentation and other people fix bugs, because the documentation thing allows fewer interactions with people asking questions. It looks like this. As I said, similar to CPP-doc, you see in the table of contents for every function we have something like parameters, return value, exception safety, complexity, yada yada, and then you have an example. This is for the accept function, and you see in the example over there, you see 2 calls for the accept function. So you really see, it's like the documentation is like a word in a language, and the example is like a sentence showing how this word is used. One obvious thing, if you can automate something, automate it. Closing stale issues is something we do. That means if an issue is opened and nobody reacts to it for 3 months, then it's closed. Then it's gone. If nobody's interested in taking it over, if nobody's creating a merge request, bad luck. But at least it helps to keep the issue tracker clean, because this is like free time, side project. I don't need to be reminded of things I need to do. It's about what I want to do, and it's also, for me, something for others to see. If you want to help, here's where you can help, but if nobody's interested in that, it goes away. Requesting pull request information. So also there's something from GitHub. If a computer or a robot doesn't think that the description matches what is going on, it automatically asks for that and say, sorry, can you provide more information? All right. Now we grew. We have a lot of people using it. Now it's about maintaining. It's about the step between adding new features and asking people to use it. It's more about having something out there where a lot of people interact with you, and some people think you owe them anything. Like, it doesn't work on my specific machine. Please fix that. When can I expect a release? I need this, I need that. And the first thing is, what I didn't know, there are all trolls on GitHub too. On the right side, you see some excerpts from issues and bug reports. And now I can laugh about it, but depending how much time you spend into this, you feel a bit hurt when people just come along to tell you that everything you do sucks and that you shouldn't have started in the first place. And being a C++ person, this is stupid Java style. Whoa, that's something I don't want to hear. And this is coming up every once in a while, and there's not much you can do about it. The good thing is, after a while, other people react to it too. So sometimes other people start arguing or explaining or whatever. It's not my turn, but that's at some point it's natural. I put Hacktoberfest here as well. So far, every October, people come around making crappy pull requests just to get a free t-shirt, and then I have to clean up after them, because people just come along, create a merge request where they delete a word in your README file, and basically say, I want to have a t-shirt. This year, it was the first time that or last year, that you can say, I'm not participating. Speed fetishists, people come around, just swear at you that you're not so fast as they want to expect it. And 2 words I realized that should be on a blacklist for issues. People berate you, you just need to do this and that. And you simply need to do this and that. Yeah, if it were so simple, I would have done it. And yeah, as I said, at some point, you just say, I ignore it, other people react to this, and that's the thing. But don't let the trolls win, and yeah. Then again, that's the difference between working at your day job. At your day job, you shouldn't have trolls, and if you do have them, you go to your management and you sort it out. But here is no management, you can't sort that out. And now we come to the good things. If you have a community, you don't need to do everything yourself. Google OSS fuzz integration was done by an engineer from Google. So basically, they informed me, we integrated your stuff in OSS fuzz. And in case you're wondering, OSS fuzz is this and that. Say, oh, okay. And here's a bug tracker where we generate the bugs that we found. Here's the credentials. I didn't do anything about this. Immediately got new bugs for free. Package managers. I implemented one, homebrew. All the others were implemented by other people. And that's really nice, because I don't even know what all these new package managers are about. Other people create a merge. Sometimes they need a merge request to mention it in the README, but others are just, oh, I wanted to inform you, you're now in whatever. Language bindings. For some reason, people write language bindings because as if JSON was not supported by other languages. Why not? And here's a slide from QtDevCon22 by Microsoft, where on the last line, they say, finally, we can compile JSON for modern C++ in 2016. And then that is nice that this happens and you don't need to interact too much with it. Another lessons learned that doesn't work in company world, unfortunately, I stopped responding to emails. I have an email template that you see on the right, where I basically thank them for reaching out, explaining to them that I don't do support via email. I want to have everything in GitHub. Public communication is helping for others. Other people can see this. People can react on this. Emails just don't scale. Same with Twitter. I tried, it doesn't scale. It's not that I get hundreds of emails, it's just some observations. People rather argue with you than opening an issue. So they reach out, send me screenshots of their Visual Studio, whatever, and say, this is broken, you need to fix it. And I said, can you please create an issue, because I'm not using Visual Studio myself. Can you please create an issue? No, I don't think that an issue is the right place for do this, because this is private code, I can't share this, etc. And then I write back and say, can you please make a minimal example where the code up? No, that's too much work, yada, yada. So that doesn't help. And then you start arguing and that doesn't help. Another thing that I realized that it seems for a lot of people, JSON, something involving JSON can be their second C++ project after Hello World. So they implement Hello World. Then the next thing they want to do is to use curl to get something from the internet and then to parse it, and then suddenly you have to explain them C++ to them, and that's also not helping. But more people just write that they like it and say thank you. I have to hurry up a bit. The community is great. I have 3 people that do a lot of work or did a lot of work. Some people are just crazy, that I see questions and before I can get my phone out, there's already an answer. I had one guy, Theo, he developed one core feature in 6 months. So he was having that one merge request and he worked on that until everything was fine, just because he wanted to. And then after some time he disappeared. That happens, people just go away. It's good to have language lawyers at hand. If you argue with a GCC or Clang, who's right, who's wrong, then some people pull out the standard and say, oh, in paragraph 16 on that page, etc., both are wrong, it should be that way, something like this. Yeah. Next thing is you have to manage expectations. A lot of pull requests are just nice. People invest time to help you, and that's nice. But it took a long time to learn that you can also say no. A lot of people want to help, but then they're not going the extra mile. I may not be too much interested in the feature itself. And then at some point you have to say, well, if you're not going to fix it, I'm not going to fix it. That's it. And you have to learn to say no. Not every new feature is an improvement. Not every API extension is worth having. I have to learn to say nice idea. Please provide a PR. I don't need to implement it. A good idea can be implemented by anyone. And as I said, accept that some issues will never be fixed. That's just it. You have to. And the best thing is if you enforce your guidelines somehow automatically that you can say, I don't know, no test case, goodbye. GitHub can be a problem. I'm not sure whether GitLab makes it so much better, but project management is hard. Still in Git, you can't describe dependency of issues. You can't properly discuss. There are no threads. The labeling is just arbitrary words and colors, so you don't have nice workflows. They add a lot of things. It gets better, but it's really hard at some point. They allow external services, bots, that's good. The API is nice, but project management with GitHub is really a problem. All right, and the last thing is you need to understand what could be the success criteria, understand why are people using your stuff. For me, it was a lot of things. I have a slideshow on the README, so if you go on the project, there's a GIF or GIF that shows you different code examples without you doing anything. So you don't need to read too much. You just stay there and have it properly explained to you. That helps. I found a market niche. There was no JSON library that was easy to use. The timing was nice. But if you look at the graph, that is the number of stars over time. That's linear. There was not a point in time where magically it just goes up. I think it's just constant improvement and having an excellent community that helps. So much. All right, coming to the conclusion, I think I have 1 more minute. All right. To be a bit philosophical, what's the biggest challenge? It's you never know when you come back. If I lose interest in that, I don't have to hand in a resignation. I just can decide never to open GitHub again. So the biggest challenge is to leave the project in a state where basically it's easy to pick up. The second challenge is to manage expectations, to be clear about this. I'm not forced to do this. I don't need to do anything. And that's why I put a paragraph of the MIT license out there which says the software is provided as is without warranty of any kind. People forget about this. They say it's free, so you have to fix it. No. It's worth it. If I wouldn't do this, I would do anything else in open source. It's really nice to contribute something, to try something. You can play all the roles that you can have in software development. Programmer, architect, project owner, you can do QA, you can be some kind of a team lead, you can do sales, marketing. Yeah, real artistship. So you should all do open source, unless you did. And as a last thing, call for action. Maybe you can help me if you have anything up here in this list. I'm happy to answer any questions. Great to be here, and yeah, now we have time for questions.
So the microphone's there. We have our first question there.
Hello, as a fellow open source developer, how do you manage to still find time? Yes, that's the problem for me.
I do have a small kid, but he sleeps every once in a while. It's periodically. Sometimes it's just I don't work for it for a month, and then I see other people working, and it motivates me again. I think it's all about motivation, and it's about the peers that are in there. If I'm on my own, then I'm just doing what I like. But right now I have a very active guy, and it's like that guy asking you, like, can we do this today? Oh no, then I'm asking tomorrow. So it's like external motivation for this. Yeah.
Is there another question? There's a question.
If you could go back in time and change one decision, what would it be?
I guess I would have designed the core type a bit differently. Right now it's templated by the different types that come in from JSON. So you can bring your own string type, bring your own map type, etc. And it's not as flexible as I thought it would be. And I guess if I would do it differently, then I would rather think about the interfaces first and say, you bring whatever type you have as long as you follow these interfaces. Right now I'm too close to STL, and I'm making too many assumptions that if they were a bit more relaxed, it could help. And that's why the 4.0 release is so crucial, because that really is, you have that one shot, otherwise I'm at version 8 or 9 in half a year, and then it gets ridiculous.
Are there more questions in the audience? Oh, there's a question here.
With a project your size, how do you coordinate releases? Do you already know that certain bugs will be fixed in the next one, or does it happen every month or something? Or is it organic that it just happens?
Organic is a nice word to say. That it's agile. It's sometimes a release is centered around a bug, because you make a release and then you immediately figure out that you broke something. Then I have 2 releases within a week. Right now I came to the problem that there wasn't a headline feature. It was like something here, something there, and if you then not have a schedule, then it piles up, and now I think it's 50, 60 issues that will be fixed. It's terrible. I need to go to a different schedule, but at the same time, if I don't want to work on it, why should I make a schedule where I feel bad about myself? So I try to implement it in the way that a release can be a press of a button, but writing release notes is not a press of a button. So I spend now another week of not doing it. Yeah, I don't have a process for this, and this is something I need to learn. I know that there are bigger projects that just say we have a release schedule every month or every 2 months, but I guess they have more people enforcing this. So I need someone to ask me so often that I switch to that. And then basically I release the same version twice or 3 times with a different version and nobody realized it. Then that could be fine too.
There was a question here, yeah.
So fighting the trolls, you said.
Yes.
There's a saying that it takes 10 thumbs up to counter 1 thumb down.
Yes.
How do you cope with those
Says
people that try to steal your
Says the YouTuber. In the beginning, I tried to argue, and right now it's not coping with them at all. It's basically, I can close the issue, I can close discussion, and even better is, I don't react, but other people react, because other people may not even see it as trolling, because they see the question the first time, or the person the first time, so their reaction may be not what a troll expects. Like suddenly someone say, oh yeah, that's a good idea, but for this and that reason it doesn't work, and they want to get at me, or they want to get at those people that rejected him the 10 times earlier. But if other people are just coping with him, that works. It's got better over time, but in the beginning was really, I don't know where the people came from. I guess Reddit. So no, I write release announcement on Reddit because the CPP community there is nice, but apparently there are a lot of people hanging out there that have, I don't know, issues with projects. I don't know. So I guess they're coming from there. Yeah. But YouTube must be even worse, I guess.
And a follow-up to that one. So somebody brings in a valid feature, it's useful and everything, but we all know that feature also needs maintenance 20 generations ahead. How do you cope with saying, thank you, very nice, but I don't think it's worthwhile 2 years out?
Right now, if it has a proper test suite now, and I feel the value is there now, I would accept it. If it's a feature like supporting another format, like another parser, because that is, at some point can be disconnected from the rest. If people would come and say, I need 3 lines of public API, and I don't know, some returning an optional if a key exists, otherwise null, something like this. Right now I would say no, because you can write it your own. You can use a public API, It would just be adding another thing. There, I'm more hesitant if it really changes too much in the API. But if it's just another format, I would be fine. But maybe 2 years from now, it would be a stupid. This would be a stupid answer. Yeah.
Okay, there's another question from the audience.
So you mentioned the relationship between coverage and semantic versioning.
Yes.
Versioning. Can you go a bit more into that? What do you mean?
The point is, I try to have a test case for every possible or close to possible use case of a public function. If I have a function that returns you the size of a container, then I have, of course, test cases for that tries, does it make sense on a string, an array, etc., etc. And if I then can be sure that I cover all the branches and all the lines and the functions, etc., then I can be sure that if it still compiles and the tests still succeed after the next commit, then I haven't broken the public API, and that at least from that point of view, I can keep my contract. But it can, of course, be that I break the API because for reasons that are hard in C++, then I have a problem. But the coverage helps me to at least say everything that I can think about and everything the compiler can think about that can happen in this code is covered somehow, then I would be surprised if I break anyone's code.
All right. Is there another question? I would have another question myself. It would be about these compiler switches. And
Yeah.
I think we hate putting in the compiler switches. And at some times, maybe in a bright future, we can get rid of the compiler switches. Do you have tests especially for that to see like, oh, the feature just got into Clang or this feature just got into this and that compiler? So how do you keep track of all of these? And are there maybe automatic pull requests or like how does it work? Maybe converging, getting rid of those.
What kind of compiler switches do you mean now?
Yeah, you said
warnings or no, what kind of compiler switches?
in general.
If-defs.
Yeah, if-defs. Yeah, exactly.
It's all manual right now. It would be nice. I mean, we're getting there that you can somehow query the compiler and say, oh, do you know this and that? And the compiler says yes, and etc. It would be nicer if we get there. Of course, then I would at some point need to drop C++11. I think the preprocessor is still a very powerful tool, and it would be nice to have a world where we are there, but right now I don't have the feeling that even the compiler vendors would agree on such kind of an API. But yeah, it would be nice if I could just say, this API is for a compiler that supports that kind of feature level, but if you feature level, I don't know, 1, then we fall back here. But in the end, this would be then again a glorified preprocessor. We would just look differently then.
So are the if-defs getting more or less?
They're getting more systematic.
Okay.
They're coming. We try. Google Upsile is doing a nice thing. They try to detect what you have, and if you compile with C++11, they bring you a string view. And if you compile with C++17, they use standard string view. We try to be like this and have all this if-def magic in one meta header, and try to do this feature detection, and then the rest should be a bit more readable. It's more about this code comes if you do have string view support. It's not so much about are you that library with that version, etc.
All right. Then if there's no further questions, again, thanks for the question and answer session.
Thank you.